Newton died 191 years before I was born. I never met him. I never could have met him. But I need to tell you about him, because the man who saw further into nature than anyone may have been the most broken person in the history of science, and I don't know how that works. When Isaac Newton was 3 years old, his mother walked out the door. She remarried. Her new husband did not want a stepson, so she left Isaac with his grandmother and started a new family without him. She did not come back for 7 years. Everything Newton became starts here. The obsession, the secrecy, the rage. At 19, he made a list of his sins. One entry read, "Threatening my father and mother, Smith, to burn them, and the house over them." He was still angry. He would be angry his whole life, but that anger would fuel something the world had never seen. Let me go back to the beginning. Christmas Day, 1642. A tiny farmhouse in Woolsthorpe, England. A baby so small they said he could fit inside a quart mug. No one expected him to live. His father had died 3 months earlier, a farmer who could not even write his own name. So the infant Isaac Newton came into this world with nothing. No father, no money, no future. And then his mother left. For 7 years, young Isaac lived with his grandmother while his mother raised her new children in another village. He could see the church steeple of her new home from Woolsthorpe, close enough to see, too far to touch. Imagine that, a small boy standing at the window, watching the smoke rise from his mother's chimney, knowing she was there, knowing she had chosen someone else. That does something to a person. When Newton was 10, his mother finally returned. Her second husband had died. She brought 3 new children, Newton's half-siblings, and a plan for Isaac. He would become a farmer, like his father. She pulled him out of school and put him to work. Newton hated it, but here is what you need to understand. While other boys chased girls at the market, Newton sat alone, calculating. While other apprentice farmers drank at the tavern, Newton built water clocks and sundials. He would hide under trees reading books while the sheep wandered into the corn. He had no interest in farming. None. His mother's servant kept reporting that this boy would never make a farmer. But his uncle saw something else. A strange, brilliant, angry boy with a mind that would not stop. He convinced Newton's mother to let Isaac go back to school. That decision changed history. Newton arrived at Trinity College, Cambridge, in 1661. He was nobody, worse than nobody. He was so poor that he had to work as a servant to wealthier students. He cleaned their rooms. He ran their errands. He served their meals. Think about that, the future greatest scientist in history, scrubbing floors for rich boys who would be forgotten by history. The abandoned boy was still an outsider, still on. But at night, when his duties were done, Newton read Descartes, Kepler, Galileo. He taught himself mathematics that was not even in the Cambridge curriculum. He filled notebook after notebook with questions, problems, ideas. His professors didn't notice him. His classmates didn't befriend him. Newton moved through Cambridge like a ghost, invisible, watching, thinking. But in those notebooks, something extraordinary was taking shape. Newton wasn't just learning what others had discovered. He was questioning everything, challenging assumptions that had stood for centuries. He read Descartes and found errors. He studied Euclid and extended it. He looked at the mathematics of his time and saw gaps, holes, places where the tools simply didn't exist to answer the questions he was asking. Most students accept what they're taught. Newton looked at the entire edifice of human knowledge and thought, I can do better. And then, in 1665, something happened that would lock Newton alone with his mind for almost 2 years. The Great Plague swept through England. 100,000 people died in 18 months. Bodies piled in the streets of London. Entire families were sealed inside their homes to die. Red crosses painted on doors warned the living to stay away. The universities closed. Students were sent home. And 23-year-old Isaac Newton returned to that same farmhouse in Woolsthorpe, the place where his mother had abandoned him. Alone. No teachers. No laboratory. No colleagues. Just Newton, in a stone house, with nothing but his thoughts. What happened next still amazes me. Most people, isolated during a plague, would simply survive. Wait it out. Newton did something else entirely. He started with a problem that had defeated mathematicians for centuries. How do you calculate the area under a curve? How do you describe the way things change? Think about what that means. If you want to know how fast something is moving at a single instant, not over a period of time, but right now, how do you calculate that? The Greeks could not do it. The Arabs could not do it. No one in 1,000 years had figured it out. Newton did not just solve it. He invented an entirely new branch of mathematics. We call it calculus. In a few months alone, Newton created the tools that would let scientists describe motion, change, and the physical world with precision that had never existed before. Every engineer who designs a bridge uses calculus. Every physicist who models a star uses calculus. Every economist who predicts a market uses calculus. Newton invented it in his bedroom during a plague at 23, but he was not done. He cut a small hole in his wooden shutters. He let a beam of sunlight pass through a glass prism, and he watched white light spread into a rainbow on the opposite wall. Everyone knew what a prism did. No one knew why. For 2,000 years, people believed that prisms somehow colored the light, that they added something to it. Newton suspected the opposite. He figured it out. White light is not pure. It is a mixture of every color. The prism does not create the colors. It separates them. Then he took a second prism and recombined the colors back into white. He had discovered the true nature of light. And still, he was not done. He looked out the window at an apple tree in his mother's orchard, and he asked the question that would unify heaven and earth. Is the force that pulls an apple to the ground the same force that keeps the moon in orbit? This question might seem obvious now. It was not then. For 2,000 years, people believed that earthly things and heavenly things were fundamentally different. Rocks fall because they are made of earth, seeking their natural place. The moon orbits because it is made of celestial matter, following divine paths. Newton looked at the moon and saw a rock, a very big rock, falling toward Earth, but moving sideways fast enough that it keeps missing. That's what an orbit is. Falling and missing. Forever. Think about what I'm telling you. Calculus. Optics. Gravity. One man. 18 months. Alone in a farmhouse. Newton calculated that if gravity weakened by the square of the distance, twice as far means 1/4 the force, then the moon's orbit made perfect mathematical sense. The same force that drops an apple holds the planets in their paths around the sun. Before Newton, the heavens were divine, untouchable, governed by different rules than our earthly world. After Newton, there was just physics. The same equations everywhere. In 18 months of isolation, the abandoned boy had discovered how the universe works. And then, he did something I still don't understand. He hid it. Newton told almost no one what he had discovered. He wrote up some results. He showed colleagues bits and pieces. But the full scope of what he knew, he kept it locked away for 20 years. Why? Because Newton trusted no one. He had been abandoned by his mother. He had been mocked for his early work on light. When he first published his theory of colors, Robert Hooke attacked it publicly. The criticism wounded Newton so deeply that he withdrew from scientific society entirely. Every time he shared something, it brought him pain. So the greatest scientific discoveries of the century sat in Newton's desk drawer. While other scientists struggled with problems Newton had already solved, he said nothing until 1684. A young astronomer named Edmund Halley visited Newton at Cambridge. Halley had been arguing with Robert Hooke and Christopher Wren, three of England's finest minds, trying to solve the same problem. What mathematical curve would a planet trace if pulled toward the sun by a force that weakened with the square of the distance? Hooke claimed he knew the answer, but would not show his work. Wren offered a prize to anyone who could prove it. No one could. So Halley went to see the strange, reclusive professor at Cambridge. He asked a simple question. If gravity follows an inverse square law, what shape would a planet's orbit be? Newton answered immediately. An ellipse. Halley was stunned. How do you know? I calculated it, Newton said. Years ago. Can I see? Newton could not find the papers. He had done the work and lost them, but he promised to redo the calculation. 3 months later, Newton did not send Halley a few pages. He sent him the beginning of the most important scientific book ever written, the Principia Mathematica, published in 1687. Halley paid for it himself because the Royal Society had spent its money on a book about fish. Think about that. The most important scientific work in human history almost did not get published, and only exists because one man believed in it enough to empty his own pockets. 3 laws of motion. The law of universal gravitation, a complete mathematical framework for understanding reality. Newton showed that the same mathematics that describes a cannonball describes a comet. The same force that makes you fall when you trip keeps the moon from flying off into space. Before Newton, people believed the heavens followed different rules than Earth. The planets moved in divine circles. The stars were unknowable. After Newton, there was only physics. The same equations that describe a falling apple describe the moons of Jupiter. Newton had unified heaven and earth. The Principia changed everything. Within a generation, scientists across Europe were using Newton's methods. Engineers built better machines. Astronomers predicted eclipses with perfect accuracy. The Industrial Revolution that would transform human civilization rested on foundations Newton laid. But here's what you need to know about the man behind the equations. The same mind that could hold a problem for 20 years. That same mind held grudges forever. Robert Hooke was a brilliant scientist. He had suggested that gravity might follow an inverse square law. He wanted credit. Newton refused. Not only refused, he went through the Principia and systematically removed every reference to Hooke he could find. Their feud lasted decades. When Hooke died in 1703, Newton became president of the Royal Society. Shortly after, the only known portrait of Robert Hooke disappeared. We don't know what happened to it. We don't even know for certain if such a portrait ever existed. But when the Royal Society moved to new premises in 1710, Hooke's image, if there was one, was gone. To this day, we don't know what Robert Hooke looked like, one of the most important scientists of the 17th century, and we cannot put a face to his name. And Newton wasn't finished. Gottfried Leibniz, a German mathematician, had independently developed calculus. This happens in science. 2 people working separately sometimes reach the same discovery around the same time. But Newton couldn't accept it. He accused Leibniz of theft. He stacked a Royal Society committee with his allies. The committee's report, which Newton himself secretly wrote, declared Leibniz had stolen Newton's ideas. The battle consumed both men's final years. Leibniz died in 1716, largely abandoned and disgraced. No one from the Royal Society attended his funeral. Newton won. But look at what winning cost. The man who understood gravity couldn't forgive a single slight. The man who unified the cosmos spent his final decades destroying rivals. The abandoned boy, still fighting, still angry, still alone. So why do I revere this difficult, broken man? Because everything I ever did rests on what Newton built. Let me tell you something. When I was in high school, my physics teacher, Mr. Bader, pulled me aside. He said, "You look bored. Let me tell you something interesting." He told me about the principle of least action. Newton's laws say force equals mass times acceleration. Calculate moment by moment. But there is another way to see it. A ball flying through the air takes the path that minimizes something called action. Same answer, a completely different way of thinking. Newton gives you the rules instant by instant. The principle of least action shows you the whole journey at once. That idea never left me. Years later, when I was trying to understand quantum mechanics, I asked what happens to the principle of least action when particles behave like waves. And I discovered something. In quantum mechanics, a particle does not take one path. It takes every possible path. Each path adds a tiny arrow, a probability amplitude. and you sum them all. The crazy paths cancel out. The sensible paths add up. And Newton's physics emerges from the quantum chaos. I built my path integral formulation on foundations. Newton laid 3 centuries earlier. That's science. We stand on each other's shoulders. Newton died on March 31st, 1727. He was 84 years old. In his final decades, he had become the most famous man in England. He ran the Royal Mint, overseeing the nation's money, and he pursued counterfeiters with the same obsessive intensity he'd once brought to physics. He personally interrogated suspects. He sent men to the gallows. He was knighted by Queen Anne in 1705. He spent years studying alchemy, trying to transmute base metals into gold. He wrote more about theology than physics, searching scripture for hidden codes and the date of the apocalypse. The man who had unlocked the secrets of the universe spent his final years chasing mysteries that had no answers. When he died, he was given a state funeral at Westminster Abbey. Dukes and earls carried his coffin. The greatest minds of Europe mourned him. According to Voltaire, who spoke to Newton's doctor and surgeon, Newton died a virgin. He never married, never had children, never let anyone close. All that brilliance, all that fame, and still alone. But near the end, someone asked how he had achieved so much, and Newton, the man who fought everyone, trusted no one, and held grudges until death, reportedly said this: "I do not know what I may appear to the world, but to myself I seem to have been only like a boy playing on the seashore, and diverting myself in now and then finding a smoother pebble or a prettier shell than ordinary, whilst the great ocean of truth lay all undiscovered before me." A boy on a seashore. That is how he saw himself. The child his mother abandoned, the angry young man who threatened to burn her house down, the genius who hid his discoveries for 20 years, the old man who erased his rivals from history. And somehow, through all that pain, the greatest scientist who ever lived. Newton showed us that the universe follows laws, that we can understand nature through mathematics, that heaven and earth obey the same equations. He saw further than anyone, and even he knew he was just a boy, playing with pebbles, while the ocean stretched out before him. I never met Isaac Newton, but every equation I write has his fingerprints on it. And now, so do yours.